Good afternoon, class. We are looking at section 3.5, rational functions. So we covered power functions, polynomial functions, and graphs, dividing and real zeros of polynomials, complex zeros, and now rational functions. The objectives are to find the domain of a rational function, to find the vertical asymptotes of a rational function, horizontal or oblique asymptotes. Here's what we have covered, the summary of polynomial functions. F of x is a sub n x to the power of n plus a sub n minus 1 x to the power of n minus 1 all the way to a sub 0, where a sub n x sub n is the leading term. A sub n not equal to 0 is the leading coefficient. A sub n x sub n is the leading term, and a sub n is the leading coefficient. N is a whole number where whole numbers are from 0, 1, 2 to infinity. Domain is our real numbers. A polynomial of degree 1, y equals mx plus b, is a linear function, or p of x. P of x equals ax squared plus bx plus c is a quadratic function where x is minus b over 2a is the location of a vertex, and f of minus b over 2a is the y-coordinate. Degree of a polynomial n, graph is smooth and continuous. Maximum number of turning points would be n minus 1. At a 0 of even multiplicity, the graph of f of x touches the x-axis. At a 0 of odd multiplicity, the graph of f of x crosses the x-axis. Between zeros, the graph of f of x is either above or below the x-axis. End behavior. For large values of x in the negative or positive sense, that means absolute value of x, the graph of f of x behaves like the graph of its leading term, y equals a sub n, x to the power of n. Zeros are polynomial function. N of x divided by d of x is equal to q of x plus r of x over d of x, where d is the divisor, q is the quotient, r is the remainder. Or n of x is q of x times d of x plus r of x. Dividend is quotient times divisor plus remainder. The remainder theorem, if we are dividing f of x by x minus c, the remainder is f of c. And the factor theorem says if this r that we calculate here is 0, that means x minus c must be a factor of the function f of x. The IVT, or the intermediate value theorem, indicates if f of x is a polynomial function or any continuous function. And if for real numbers a and b, the values f of a and f of b are opposite in sign, then there exists at least one real zero between a and b. Number of zeros theorem, a function defined by a polynomial of degree n has at most n distinct unique zeros, complex zeros. The rational zero theorem indicates that if f of x is in the format that was mentioned before, then all possible rational zeros are in the form of p over q, where p is a factor of the a sub 0, the constant, and q is one of the factors of a sub n, the leading coefficient. Fundamental theorem of algebra. If p of x is a polynomial of degree 1 or more, then there is some number k such that p of k equal to 0. Then p of x becomes x minus k times q of x, where q of x can also be factored, resulting in the following, which results in p of x being a times x minus k sub 1 all the way to x minus k sub n, resulting in n complex zeros. Conjugate zero theorem. If p of x defines a polynomial function having any only real valued coefficient, and if r equals a plus bi is a zero of p of x, then the conjugate r bar a minus bi is also a zero of p of x. Odd degree polynomials have at least one real zero, since complex conjugate zeros happen in pairs. This is 1, everybody. Okay, so we're gonna move on. 1, that's important to understand. All right. Now, section 3.5, rational functions. A function f is a rational function if f of x is n of x over d of x, and d of x can't be 0, where n and d are polynomials. Remember, in the case of rational numbers, the top and the bottom are integers. In the case of rational functions, the top and the bottom must be polynomials. The domain of f consists of all real numbers except the zeros of the denominator of f of x, which is d of x. So you set d of x equal to 0 and you exclude it. Arrow or limit notation is used to show that x or f of x is approaching a particular value. We discussed this with more details in calculus. So this one, x approaches a. This is a from the left. X approaches a from the right. For example, if a is 5, this means like 4.9999. If a is 5, this means 5.00001. That's the meaning of a from the left, a from the right. X is approaching infinity. X is approaching negative infinity. F of x approaching infinity. F of x is approaching negative infinity. F of x is approaching a. And of course, f of x is the y coordinate or the output, if you will. Whereas x is the input. So, for example, a function such as this one, you can see that this means as x approaches infinity, f of x is approaching the y-axis, or y equal to 0. Over here, as x approaches 0 from the right, f of x approaches infinity, it blows up to infinity. This one, as x approaches negative infinity, f of x approaches 0. That's the definition of a horizontal asymptote. This is going down. As x approaches 0 from the left, f of x approaches negative infinity. That's the definition of a vertical asymptote. So for example, for this graph, what do we notice? The limit of f of x as x approaches negative infinity, it crosses the horizontal asymptote and it goes along this line, y equals 0.6 or 3/5. The same thing as x approaches infinity, the limit of f of x as x approaches infinity is also 3/5 or 0.6. So pay attention to this concept. Okay. Asymptotes, horizontal, vertical, oblique, or slant, where the function y equals f of x. Definition. Horizontal asymptote, short HA, of the curve y equals f of x is y equals L if the limit of f of x when x approaches negative infinity is L, or limit of f of x as x approaches infinity is L. So as you can see in this graph, as x goes towards infinity, the graph seems to be run along the line y equals L. On the other hand, in this case, as it's going this way towards negative infinity, runs along the line, and therefore we have this one. So limit of f of x as x approaches negative infinity is L, or limit of f of x as x approaches infinity is L, then y equals L is the horizontal asymptote. Look at this one. What's happening? As x approaches a from the left and from the right, it goes up, or in this case, from the right goes to infinity, from the left goes to negative infinity. Vertical asymptotes, short VA, of the curve y equals f of x is x equals a, if the limit of f of x as x approaches a is plus or minus infinity, or limit of f of x as x approaches a from the left is plus or minus infinity, or limit of f of x as x approaches a from the right is plus or minus infinity. In short, just look at the graph. It blows up to infinity on either one side or both sides. In that case, x equals a, and infinity or negative infinity, gives rise to what we call a vertical asymptote. And finally, we have, of course, if the function is in lowest term, all you have to do is set the denominator equal to 0 and find its vertical asymptote. First, you make sure if there's a common factor, you drop between the two. Slant or oblique asymptote, OA or SA for that matter. The limit of f of x as x approaches minus infinity is mx plus b, or the limit of f of x as x approaches infinity is mx plus b. It approaches some sort of a slant line, okay? That's why it's called oblique or slant asymptote. Again, very straightforward, everybody. So that's the synopsis of asymptotes. F of x equals mx plus b plus r of x, SA is mx plus b. In other words, you divide the numerator by the denominator. It creates the quotient, which is a line, and the remainder, the quotient, y equals the quotient mx plus b, is the equation of slant asymptote. All right, find the domain of a rational function. So let's see how we find that. Let's start with this one. In short, you set the denominator equal to 0 and you exclude it. So in this case, x plus 1 is 0. That means x equals negative 1. And that means x can't be negative 1. In an interval notation, this is how you write it. Very straightforward. What about this case? You do the same thing. X squared minus 4 is 0. X squared is 4. X is plus minus 2. And you exclude it. So you factor the denominator. And then you exclude 2 and negative 2. So you could say, use a different color. Actually, let me clean up and write. So x can't be plus minus 2. Shorthand notation. Interval notation. Negative infinity to negative 2 union, negative 2 to 2, union 2 to infinity. That is the domain. H of x equals x cubed over x squared plus 7. If you set, I hope you recognize if you set x squared plus 7 gives you no solutions. This is the shorthand notation 5 for sure. Because x squared plus 7 is always greater than or equal to 7, okay? So what's the domain? All real numbers, okay? There's no restrictions. What about this case? Here's what you want to be very careful. We may be tempted to say, well, x can't be 3, and that's true for the domain, but it's not true for the vertical asymptotes, because I want to go back to all of this and say x equals minus 1, is a vertical asymptote. X equals -2, X equals +2 is a vertical asymptote. This guy doesn't have it. This one doesn't have a vertical asymptote either because the numerator gets factored into X plus 3, X minus 3. And you're going to say it's equal to X plus 3 and X can't be 3. This is the domain, meaning negative infinity to negative 3 union, positive 3, why did I say negative? 3 union 3 to infinity. But you can't say X equals 3 is the vertical asymptote. And that's the idea that I want to discuss actually the next part. We want to find the vertical asymptotes of all of those, which means for this one, X plus 1 equal to 0, X becomes -1. Denominator is 0, the factored form equal to 0, X is plus -2. There are two vertical asymptotes. This one, X squared plus 7 equal to 0 doesn't produce any solutions, so there is no vertical asymptotes. This one, X minus 3 cancels out, so class. Although X minus 3 equal to 0 gives you X equals 3, that means X can't be 3, okay? That means it's going to have an effect on the domain. That means the graph is the same as this line, but there's a hole. This is a line Y equals X plus 3. So this one has no vertical asymptote because X minus 3 cancels out. And that's important for everybody to recognize, okay? This is extremely important, everybody. All right, let's discuss multiplicity and vertical asymptotes. How do they work? As you can see, they all have a vertical asymptote at X equals 2. Because if you look at the concept of a limit, okay, this one as X approaches 2 from the left goes to negative infinity, from the right goes to positive infinity. This one is vice versa, and this one as X approaches 2 from the left and right, both of them go to infinity. In this case, both of them go to negative infinity, which means X equals 2 is a vertical asymptote in all cases. But this is odd multiplicity, so is this one, which means the denominator for this 2 is X minus 2 to the power of odd. It's just maybe just X minus 2. However, look at this one. Because both sides have the same sign, then X minus 2 must be the power of even. This one, the same thing. Both sides have the same sign. In this case, positive. In this case, negative. So X minus 2 to the power of even, maybe X minus 2 squared. Okay, that's the idea. So finding the vertical asymptote is very simple. So after you simplify and put the rational function in its lowest term, you set the denominator equal to 0. What about horizontal oblique asymptote? When the function is in the form of n over d, and we say this is a sub n x to the power of n all the way to a sub 0, whereas this one is b sub m x to the power of m all the way to b sub 0. The degree of the numerator is n, the degree of the denominator is m. If n is less than m, then the horizontal asymptote y equals 0. If n is equal to m, ultimately these two take over. And since x to the power of n and x to the power of m are the same because n equals to m, they cancel each other. So the leading coefficients, a sub n over b sub m, y equals that, equals the horizontal asymptote. If the degree of the numerator is larger by precisely and only 1, has to be only 1, then you can divide, long division or synthetic division, and you get a first degree quotient, mx plus b, with some remainder over d of x. Oblique asymptote is the quotient, y equals mx plus b. Those are the methodologies. So pretty straightforward, everybody. We are going to move on. All right. We want to find all asymptotes. If you look at the very first one, we want to find the vertical asymptote. We're going to set the denominator equal to 0. There is no vertical asymptote. Here's the reason. X squared plus x plus 1 equals 0. This can never be 0 because b squared minus 4ac equals, look at this one, a is 1, b is 1, c is 1. So 1 squared minus 4 times 1 times 1 equals negative 3. When b squared minus 4ac is negative, there is no real solutions. Okay, everybody? We don't have a real solution. It's that simple. And therefore, there is no vertical asymptote. There is no vertical asymptote, everybody. Horizontal asymptote, y equals 0. Y is that? The degree of the numerator, everybody. What is the degree of the numerator? Where the numerator is 1. Where the denominator is 2. The degree of the numerator is smaller than the degree of the denominator. So degree of, I'm going to say n of x. I'm going to, by n, I mean the numerator is less than the degree of the denominator. That's why. And when you have horizontal asymptote, you don't have oblique asymptote and vice versa. So you have only one of them. Class, we either have vertical asymptote, horizontal asymptote or oblique asymptote. We can't have both. Either or. Since we have a horizontal asymptote, there is no vertical asymptote. All right, so for part B, we're going to put 4x squared minus 1 equal to 0. We can factor it into 2x minus 1, 2x plus 1, or you can say 4x squared equals 1x squared is 1/4, you get plus minus 1/2. So I hope you see that, or the second method, let me use a different color here. Right here, you could say 4x squared equals 1, x squared is 1/4, x is plus minus the square root of 1/4, which is plus minus 1/2. In other words, you have a choice, and you can do it either way. Okay. And like I said, either way it's fine. What about horizontal asymptote? It's equal to 2. Why is that? The degree, let me use a different color. The degree of the numerator is 2. The degree of the denominator, degree of n and d is 2. So y equals 8/4 is the answer. And because you have a horizontal asymptote, there is no oblique asymptote. There is no oblique asymptote. Okay, everybody? I hope it's clear to everybody. Now, what's happening here? We want to find the vertical asymptote, and we get x equals -1 because x cubed plus 1 equal to 0, x cubed equals -1, and x is -1. There are 3 answers, 2 of them are imaginary, so x equals -1. However, there is no horizontal asymptote, and there is no slant asymptote or oblique asymptote. So class, from here on, sometimes I go with OA, sometimes with SA, they are the same. Why is that? The degree of the numerator is 7. The degree of the denominator is 3, the difference of 4. So either it's smaller, y equals 0 becomes a horizontal asymptote. They are identical, the ratio of the leading coefficients, horizontal asymptote. The difference is precisely 1. You do long division. In this case, long division. But if it's more than 1, we don't have any of those. No horizontal asymptote, no slant asymptote. Again, on purpose, OA, and I put SA, they are identical, okay? We want to find a slant asymptote. That means we have to do long division. Because the denominator is x minus 3, we can also do synthetic division. Either way is fine. By the way, x equals 3 is the, let me in fact write it quickly. X equals 3 is the VA they didn't ask. Okay, vertical asymptote. So do the division. To do the division, as you recall, you divide the first term by the first term, you do the approximation, you get 2x. You multiply the 2x by the divisor x minus 3, you get 2x squared minus 6x. You subtract this, so this becomes negative, cancels this one, this becomes positive, and it becomes 7x. You drop the -1. You divide 7x by x, you get 7. You multiply it by the divisor, you get 7x and minus 21. Because you're subtracting, should be like so, okay. You see that they cancel each other. This becomes plus 21 with -1 becomes plus 20. Therefore, this is your quotient. Y equals 2x plus 7 plus 20 over x minus 3. Y equals 2x plus 7 is the slant asymptote or oblique asymptote. Slant asymptote or oblique asymptote, okay, everybody? Find the domain and identify all asymptotes of a rational. We're going to go through this fast. Set this equal to 0. X equals 3 is VA or vertical asymptote. Set 3 minus x equal to 0, x equals 3. Horizontal asymptote. Degree of the denominator, if the numerator is 1, last degree is 1, so is this one. So it gives you 4x over minus x. Y equals -4 is the horizontal asymptote. There is no oblique asymptote because you have either or. What about the domain? Here's how the vertical asymptote helps. Everything except that. So that means -infinity to 3, union 3 to infinity. Let's look at this one. Vertical asymptote. X is plus minus 1. Horizontal asymptote, we don't have any. The degree of the numerator is 3, the degree of the denominator is 2. You have to divide, and I'm going to leave it for you to do that. And that gives rise to an oblique asymptote of 2x. Okay? You divide the top by the bottom. The quotient y becomes 2x, and y equals 2x is the answer. So this one class, I'd like you to do this afterwards on your own. But y equals 2x is the oblique asymptote. You can try it, you'll see that. That's all there is to it. And what about the domain? Well, x is plus minus 1 is the vertical asymptote. Everything except those two numbers. How do you write it? Minus infinity to minus 1, union -1 to 1, union 1 to infinity. That's how we write it. All right, let's look at this one. Vertical asymptotes. Set this equal to 0, x is plus minus 3. The degree of the numerator is larger than the degree of the denominator by 2. We don't have horizontal asymptote. We don't have oblique asymptote. Oblique asymptote, there is a precise difference of 1. And so what is the domain? What is the domain? Just exclude these two numbers. -infinity, -3, union -3 to 3, union 3 to infinity. Pay attention to the way we write the interval format. What about this one? F of x is 2x over x squared plus 1. VA, as you can see, it's x squared plus 1 set to 0, and there is no solution. I hope you understand. If you have x squared or x to an even number plus a number can never be 0. So there is no vertical asymptote. X squared plus 1 equal to 0. That gives us no solutions. That takes care of that. What about horizontal asymptote? The degree of the numerator is 0, is 1, my apologies, why did I say 0? The degree of the numerator, okay, the degree of the numerator is 1. The degree of the denominator is 2. Because the degree of the numerator is smaller than the degree of the denominator, horizontal asymptote y equals 0. Of course, we don't have oblique asymptote. What about the domain? There's nothing to exclude, all real numbers. When you set the denominator equal to 0 and doesn't produce any solutions, that means everything is fine. That means domain is all real numbers. You can write it in this format. Or in this format. Negative to positive infinity. They both mean the same thing. All real numbers or negative to positive infinity. Now we are ready to actually graph rational functions. Now that we understand how this stuff works, we know how to find the domain, we know how to find the asymptotes, and so on. So let's start with the intercepts. Intercepts, just like any other intercept, x is 0, find y is 0, find x. So if I want to find x-intercept, I set y equal to 0. Please understand g of x is the same as y. This is the same as y. Now, a fraction is 0, class. A fraction is 0 if a is 0. A fraction is 0 if the top is 0. So when you set this equal to 0, then x becomes 1, and that's your x-intercept. Okay? So you set y or g of x equal to 0. You set the numerator equal to 0, and x becomes 1, and so you have 1, 0. So you locate the 1, 0, 1, 0. Y-intercept, you set x equal to 0. So class, if I set x equal to 0, I get what? 0 minus 1. 2 times 0 is 0 over plus 1. I get negative 1, which means 0, negative 1. That's the y-intercept, or f of 0. Y-intercept or f of 0. Very straightforward, everybody. Zero, negative 1. Asymptotes, let me clean up my work. VA, 2x plus 1 is 0. X is negative 1/2. Horizontal asymptote. So that's your vertical asymptote. X equals negative 1/2. And horizontal asymptote, y equals 1/2. No slant asymptote. Y is that. Let's go back to the top. Notice this is degree 1. This is degree 1. So x over 2x equals 1/2. That's how you get that in essence. Okay, everybody? That's how you get this as the answer. And of course, if you have a horizontal asymptote, you can't have a slant asymptote. So this is your horizontal asymptote, the blue one. What about the domain? Well, we go back to the vertical asymptote, and we say everything except x equals negative 1/2. Everything, all real numbers except x equals negative 1/2. So in an interval format, we write negative infinity to negative 1/2 union negative 1/2 to negative infinity. Now, here's what I want to tell you when you graph a rational function and you have two asymptotes. Couple of things. First and foremost, it must be checked whether it crosses the horizontal asymptote. It may, which means what? You set the, let me erase the work again. You set the function, original function, equal to the value of horizontal asymptote. So you set this one equal to 1/2 and you solve. It either gives you a solution, so it gives you x, you plug it back in, you find the y, and that's your pair where it crosses, or it doesn't give you any solution, that means it doesn't cross. If it doesn't cross, the graph on the right side, look at your vertical asymptote. is either this one or this one. Obviously, since you have this point, these 2 points has to be this. So you don't have this top piece, because if you do, then it can't be a function. For the left side is either this one or this one. Okay. So again, just for the sake of argument, for the left side either looks like that or looks like that. And by the way, you may notice it can't be looking like that, because if it does, it has to be another x-intercept. We don't have it. So it has to be like that. But in any event, let's do a simple way of finding an extra point. So here's your vertical asymptote, x equals -1/2. To the left of it, an easy point would be -1. Put -1 here. You get -1 minus 1, which is -2. And you put -2 plus 1, you get -1, -2 over -2. -2 over -1 is +2. So one more time, if you plug in -1, if you change this to -1, you get -2. If you change this to -1, you get -1. And that's how you get this pair. Okay? And that's the pair. Now, as I mentioned, does the graph cross its horizontal asymptote? You must set the equation equal to the equation of the asymptote. So you set this equal to this. And you do the cross product and you try to solve. So this is 2 times x minus 1. This is 1 times 2x plus 1. You get 2x minus 2 here. You get 2x plus 1 here. And I hope you recognize that these two cancel each other. Minus 2 equals 1 is a f false statement. Okay. Minus 2 equals 1 is a false statement. That means no solutions. That means no, they don't cross. And now if you graph, this is what you get, everybody. So this was clear. And this one, we came up with one more point. We have the graph. That's all we do to graph any rational function. We go through the process. We want to sketch the graph of f of x equals x squared minus 4 over x minus 2. The very first step in graphing any rational function is to put it in its lowest term if possible. You can see the top is x minus 2, x plus 2. Which means f of x equals x plus 2 and x can't be 2. In other words, in essence, this means we are looking for the line y equals x plus 2, where x can't be 2. And what it does, it creates a hole at that point. So we can graph y equals x plus 2 by picking up 2 is 0.02, -2, 0. Those are the intercepts, everybody. Those are the intercepts. Very easy. Where does the hole occur? We said x can't be 2. If you plug in here, you get 4. So it's 2 and 4. So you draw the line. And let me just put this. This is not to scale class, but this is 0, 2. This is -2, 0. If you look at the scale along the x and y axis, this is different than this one. So this is 8. So that's why it makes this one 2. So it's important to know that it doesn't have to be the same. Okay. The scale They don't have to be the same. So it's pretty straightforward, everybody. It's important to know not every rational function has asymptotes, or for that matter, becomes a rational function that you know it. In this case, becomes an easy line with a hole. So again, how do you locate the hole? If you put what it cannot be in there, it gives you the pair. All right. We want to graph f of x equals x squared plus 3x plus 2 over x minus 1. And we're going to do the same thing when we find the intercepts, asymptotes, and a few points and graph. And first and foremost, if you can, you must factor the numerator, the denominator. Number one, if there's a common factor, you drop it. Number two, it makes it easier to come up with the intercept. So if you factor the numerator, you get x plus 2 times x plus 1 over x minus 1. Nothing cancels out, so that's fine. Let's find the intercepts. So let's find the x and y intercept. To find the x-intercept, you set y, that means f of x equal to 0. I want to make sure that we do this, and I'm going to erase it. So y or f of x equal to 0, that means the top is 0. The numerator is 0. And that creates negative 2 comma 0, negative 1 comma 0. I hope you see that. So this one gives you negative 2, this one gives you negative 1, and therefore those are the answers. And by the way, denominator is 0, that means the function is undefined or it gives rise to asymptotes. Let's find the y-intercept. To set the y-intercept, you set x equal to 0. It's easier to go this route for the y-intercept. You basically say f of 0, which means 2 over negative 1. Again, notice everybody, if x is 0, this goes to 0, so just 2. This goes to 0, just negative 1. 2 over negative 1 or negative 2, so 0, negative 2. So by the way, these are the two x-intercepts, negative 2, 0, negative 1, 0. And now this is your y-intercept, 0, negative 2, and that's 0, negative 2. I'm going to hold on to this and I'm going to erase it in a moment. Vertical asymptote is very simple. The denominator is 0, x equals 1. So asymptotes, VA, vertical asymptote short for vertical asymptote is VA, and we get x equals 1. Now, the degree of the numerator is 2, the degree of the denominator is 1. The difference of 1 says there is no horizontal asymptote, there is a oblique asymptote. We can find it either by the long division or synthetic division. So here's the vertical asymptote. Let's draw the vertical asymptote. We are going to divide the top by the bottom using the long division. All right, so to do the long division, you divide the first one by the first one, you get x. You multiply by it, you get x squared minus x. You are subtracting, this becomes negative, this becomes positive. And they two cancel each other and they add up to 4x. You drop the 2. You divide 4x by x, you get 4. You multiply it, you get 4x minus 4. You subtract from it, this becomes negative, cancels this one, this becomes positive, we get 6. So we have the quotient x plus 4, we have the remainder 6. This can be done by synthetic division. So you can write 1, 3, 2, and for this one you put 1. I want to show you both methods just to remind you of what we've done. So the 1 drops. okay? And then you multiply this one by 1. Always you multiply by this number, okay? Multiplied by 1. Then add these two, you get 4. Multiplied by 1. You add these two, you get the same answer as before. And since this is degree 2, you go down by 1, you get this is 1x or simply x. This is 4, and this is the remainder just as you have it here. So y equals x plus 4 is your oblique or slant asymptote. Now, this is a line, and to graph it, we can pick two pairs. The y-intercept is 0, 4. The x-intercept is negative 4, 0. And plot those two pairs, and you get this. And let me erase the extra stuff. So we have the vertical asymptote, we have the horizontal asymptote, and basically here's what's happening. On the right side, it's either like so or like so. On the left side, it's either like so or like so. Remember, it's very easy to see. To the left side, you have these 3 points. So you clearly have this part. There's nothing you can do. Because if you were to have this part, that means there is another y-intercept, not this one, and we don't have it. For this part, it either goes here, which means we must have another x-intercept we don't have. So it must be in between. But pick up a number. Since we have everything on the left, pick up a number, extra point on the right. Okay, x equals 1, so pick 2. If you plug in 2 here, you get 2 squared, 4 times 3 times 2, 6 and 4, 10 and 2, 12. 2 minus 1 is 1. You get 2 and 12 is somewhere here. And that's the graph. Roughly, it has to go between them. And so you have the answer. Very straightforward, everybody. I hope everybody is okay with this. So the details is explained as to how we come up with the answer. To recap, you find the intercepts. X is 0, find y. Y or f of x is 0, find x, just as before. You find the asymptotes. VA, the denominator is equal to 0. Then you either have horizontal asymptote, oblique asymptote, or none of the above. The degree of the numerator is smaller or equal to the denominator. The degree of the denominator, we have horizontal asymptote. If it's larger by 1, we have oblique asymptote. The methodology is the long division. In this case, we could have used the synthetic division as well. That's why we could do that. Otherwise, you can't. Okay. And we have the graph. How about this one? We want to sketch this graph. R of x is x minus 1 over x squared minus 4. And we are going to factor the top and the bottom. The top, there is nothing we can do. The bottom is x minus 2, x plus 2, because it makes life easier for the rest of it. As far as the domain is concerned, class, all real numbers except plus minus 2. So you would say from negative infinity to negative 2, union negative 2 to 2, union 2 to infinity. Intercepts. X is 0, find y. Y is 0, find x. For x being 0, it's easier to go here. If x is 0, forget about this one. You get minus 1 over minus 4. So when x is 0, you get 1/4. So 0, 1/4. Class, if x is 0, you get 0 minus 1. 0 minus 4, you get 1/4. So you get 0, positive 1/4. If y is 0, you set the numerator equal to 0, y equal to 0. That means r of x equal to 0. a fraction is 0 when the top is 0. That means x minus 1 is 0. That means x equals 1. That means 1, 0. So these are the intercepts. Let's clean up. Let's put those two on the graph. We have 0, 1/4. We have 1, 0. Vertical asymptote, x equals 2, x equals -2. You set the denominator equal to 0. Okay, so you set x squared minus 4 equals x minus 2 times x plus 2 equal to 0. And that gives us x equals -2. That also gives us x equals 2. So those are the two vertical asymptotes. So x equals -2, x equals +2. Horizontal asymptote, y equal to 0. Why is that? Degree of the numerator is 1, degree of the denominator is 2. Degree of the numerator is less than the degree of the denominator. So y equal to 0, or simply the x-axis. Is, you don't have to draw anything, but just to emphasize. Therefore, there is no oblique asymptote. There is no oblique asymptote class. So does the graph cross its horizontal asymptote? We don't know. We set the function equal to this. In fact, we already have the answer, okay, 1, 0. Because when you set this equal to 0, that means you set the numerator equal to 0, and we already knew that. So yes, it does. At the x-intercept of 1, 0, it does. There's no oblique asymptote, as it was mentioned, because you can't have both. Now, what about extra points, and how do you find them? You look at your vertical asymptotes. X equals -2, x equals 2. That cuts the entire interval into 3 subintervals. If we go from negative to positive infinity. So to the left of -2, okay, between -2 and 2, and beyond the 2. So this is not that important. You can use that. But what we are interested in, to the left of -2, between these two, for example, you can even pick up number 1, but it already has the answer. In fact, in between, we have these 2 points. So the graph either looks like this or looks like this. It can't look like that, just to let you know, because it crosses these 2 points, it has to look like that. But in any event, and of course, beyond the 2. So to the left of -2, you can pick a point and plug in. For example, if you put -3, you get -4 over 9 minus 4, which is 5. You get -3, -0.8. Just to let you know, class, if you plug in, for example, -3, you get -3 minus 1. The bottom is -3 squared minus 4. Get -4 over 9 minus 4, which is 5, or -0.8. Over here, between -2 and 2, you can get, for example, -1 here, for example, 3/2 here. To the right, if you plug in 3, by the way, you get the same answer, but positive, okay? So -1, if you plug in, let's do also -1, so you see how easy we can. Again, try 2 is the same number, but negative becomes positive here. But -1 as an example, if I plug in -1 here, I get -1 minus 1 over -1 squared minus 4, which I get -2 over -3, or 2/3. So I get this points. Again, quickly, I want to, -3 gives you negative 4/5 or -0.8. +3 gives you the same thing, but positive. And by the way, the reason I put those because I want to, it helps me see the graph. Let's see if I put, what happens if I put 3, I get 2. Okay, I get 2 at top, not my apologies. If I plug in 3, I get 3 minus 1. I'm going to erase it. Over again, the same thing, 5. Okay, so we get 2/5 or 0.4. All right. And as I mentioned, -1, 3. And those are extra points to help us see the graph better. Let's erase this. What we really need, class, is on the left side of this and right side of this, because in between these two telling us it looks like this. In here, you either have this one or this one of the two. So let me actually graph both of them. You have, for the left side, you have either this one or this one. I'm going to call it either number 1 or 2, not both. And for this one, you have, I'm going to call this number 3. I'm going to call this number 4. You don't have both of them. Here's the reason you can't have both, because then it won't be a function. You have one of those. So you really need 1 point to the left of -2. That gives you this point. 1 point to the right of 2. In between, if you put a couple of points, fine. But as I said, these two indicate we have to go this route. Let me erase. So those are the points, the extra points. That clearly shows this one. This clearly shows this way and this way. So roughly, okay. And this is the exact, if you will. Okay, those are telling us how to graph this. All right, in this case, make up a rational function from the graph. So from the graph, we want to come up with the function. Let's see what we notice. The domain is all real numbers except -5 and 2, which means we're going to write -∞ to -5 union, -5 to 2 union, 2 to infinity. Intercepts. Here's the x-intercept, -2, 0. Here's the x-intercept, 5, 0. Here's the y-intercept, 0, -2. So we have 3 of them. This is the y-intercept, okay, 0, -2. As you look at this one, the graph crosses the x-axis. As you look at this one, the graph can't cross, meaning it has to have a multiplicity too. So what happens is that the numerator must have x plus 2 and x minus 5. So please understand, this means this. This means this. And this is multiplicity 2 because it doesn't cross. So this one must have an exponent 2. Even. We go with the smallest even number. What else do we notice? Vertical asymptotes, x equals -5, x equals 2. This one, x equals -5. This one, x equals 2. So we notice those. Which means, this means the denominator must have x plus 5 This means x plus 5 in the denominator. This means x minus 2 in the denominator. Also, for x equals 2 from the left and right, both of them go to negative infinity. In other words, the limit of this function r of x as x approaches 2 from the left and the limit of r of x as x approaches 2 from the right. From the left and right side of x equals 2, both of them go to negative infinity. That means an even multiplicity for that vertical asymptote. That means this one must have exponent 2. Okay, this one must have multiplicity 2. VA has to have multiplicity 2 at that point. I can't emphasize this enough to understand why we get there. Okay, so again, both sides go to negative infinity. This must have a multiplicity 2. Now look at the horizontal asymptote y equals 2. Now let's look at what we have come up with so far. I hope you recognize if we multiply the top through, we get x cubed, never mind the rest, over x cubed, never mind the rest. Again, the rest is not important. We are interested in the leading term in the numerator over the leading term in the denominator. They both have degree 3. However, how could y be 2? This must have a coefficient 2. Therefore, you put the coefficient 2 here. Y equals 2. That means we need a coefficient 2. I hope everybody is clear as to how we arrive at that conclusion. All right, polynomial rational inequalities. We have x minus 2 quantity squared times x plus 1 less than 0, and we want to do this by graphing. Normally, we do it with number line, but if they ask for graphing, then you have to graph that function f of x equals x minus 2 squared times x plus 1, and basically you stick with the, intercepts and the end behavior. Of course, I hope you recognize this is degree 2, this is degree 1, so this ends up being x cubed. And again, the reason the rest is not important, this gives you the, for the end behavior, not that, So to find the intercept, so that's x cubed. To find the intercept, and let me erase this. You said this one equal to 0, you get 2, 0. You get this one equal to 0, you get negative 1, 0. And this one has multiplicity 2. This one has multiplicity 1. Now, as far as the y-intercept is concerned, if x is 0, you get minus 2 quantity squared 4. Okay. And if you put this one is 0 times 1 remains the same, everybody. Okay, so it's pretty straightforward as to how we arrive at the answer. All right. Let's look at the end behavior. As it was mentioned, it looks like f of x equals x cubed. So let's put those 3 points first. We have 2, 0, 0, 4, negative 1, 0, and this one. I'm going to put an arrow, as I mentioned. We have that in calculus. And the idea behind that is it can cross And that will be helpful when we want to graph the function. What about the end behavior? As I mentioned, it's x cubed, looking like x cubed because the degree is 3 here. So first and third quadrant, that's the meaning of x cubed. So over here, it hits this one, has to bounce back. It hits this one, and at some point it has to come back. One thing is important. This one is clear where it happens, but this one, it may happen to the right or to the left or at 4, and this will be clear when we find the location of that using calculus. Okay, now let's go back to the question. We graphed it, and using the graph, we want to find where this is less than 0. That means where it's below the x-axis. So where is this function less than 0? This part, which means anywhere from -infinity to -1. There are two ways to write it: in an inequality format, x such that x is less than -1, in an interval format from -infinity to -1. And normally, with a case like this, we don't have to graph it. We can use the sign graph. How does the sign graph work? You put a number line from negative to positive infinity, and you have f of x. At -1, the function, we're going to call this f of x, right, is 0. At 2 is 0. And you pick a test point, and I'm going to call it TP for short. Okay, test points. So we're going to put TP for short. Over here, like you pick -2. Over here, you like between negative and positive, the best choice would be 0. And for example, here 3. So what do? You put that into this expression, and you see whether it becomes positive or negative, okay? So for example, if I put -2 into this one, it doesn't matter, into this one. -2 and -2 is -4 squared. Becomes +16. -2 and 1 is -1 times +16 is negative. So this is negative, okay? And to the right of it, for example, 0, if you plug in 0, this becomes -2 squared, which is 4, and then 1, that's positive. By the way, 2, because of the multiplicity, if this is positive, both sides have the same sign. But you can plug in 3 and observe that's the case. We go back to the question. The question says what? Less than 0. So this is what you're looking for from -infinity to -1. This is called the sign graph. Here's an example we definitely want to do with graphing, and we do the sign graph. How does the sign graph work? Everything in the numerator and denominator you must set equal to 0. And those are important parts that give us different subintervals. So this is 0. This x equals -3. This x equals 5. This is x equal to -2. This is x equals 4. So you have a number line, and you put all of those numbers. X goes from negative to positive infinity. And all of these numbers that make the top and the bottom 0, let me just write it. The top equals 0 gives us 0, -3, 5. The bottom is 0, gives us -2 and +4. You put these numbers, all of them in order from smallest to largest. So that's why we put -3, -2, 0, 4, 5. Now, what happens at -3? This expression, let's call it f of x. Let's call this expression f of x. This expression at -3 is 0. At -2 is undefined. At 0 is 0. at 4 is undefined, and at 5 is 0. So UD, short for undefined. Now, one thing that is going to make this easy, all of them have degree 1 except this one. So at this point, the left and right are the same, but the rest of them, they alternate. So for example, I'm going to pick TP's test points. So over here, I'm going to choose -4. Over here, like -2.5. Over here, like -1. Over here, like 1. Over here, between 4 and 5, like 4.5. Over here is like 6 or 6,000. It doesn't matter. Just for the sake of argument. If you plug in -4 here, okay, we want to see what happens. We are not interested in the number. We just want the sign. So, okay, if I put -4, this becomes positive. The positive doesn't do anything. This becomes negative. This becomes negative times negative is positive. So the top becomes positive. Plug in here, negative plus 2. This is negative. Negative and negative is negative. The product is positive. Positive over positive. This one is positive, everybody. So the first one is positive. I can figure out the rest. They alternate. This alternates. This alternates. Okay. But this one remains the same because of multiplicity even. 2 is even. And then it alternates. Okay. But you can just test it by picking a point. For example, here, put -1, and here put 1 to see what happens. I'm going to leave it for you to try this. And these are the results. Let me erase my work. Okay, so this is the answer. Now, what are we looking for? Greater than or equal. So wherever you see the equality is the answer. So let's see how we write that. Here, we write -infinity to -3. And because this makes the top 0, we have a bracket. Union. Over here, we have -2 to 0. -2 makes the denominator 0 is not included. 0 makes the numerator 0. It's actually up to 4. Okay. And 4 is not included. You really have to write 0 union, but that's fine. Okay, to 4. They are not included. From 4 to 5, union, okay. From 4 to 5 is not included because it's negative. From 5 to infinity. Is 5 included? Yes, bracket. Why? Because 5 makes the numerator 0. So a quick recap. This is a plus sign, -infinity to -3. So let's just do this. This part is this part. This part is this part. And the end points, namely -2 and 4, belong to the denominator. Therefore, parentheses. And finally, let me use a different color. This one. This part, oh, I didn't use a different color. This part is this, okay? This part is this. It's pretty straightforward, everybody. Solve x² -4 over x² -9 greater than or equal to 0 by graphing f of x equals x² -4 over x² -9. Again, normally we do it by the sign graphic. It makes more sense and it's easier. But in any event, let's do it with the graphic. To graph this, we are going to first and foremost factor the top, factor the bottom. This is x plus 2x minus 2. This is x plus 3x minus 3. And so nothing cancels out. The next one is to find the intercepts. Intercepts. If you want x-intercepts, you find y and you set equal to 0. So f of x or y equal to 0, that means the numerator is 0. The numerator gives you plus minus 2. Again, x-intercepts y or f of x equal to 0. That means this is equal to 0. X is plus minus 2. That means negative 2, comma 0, positive 2, comma 0. If you want the y-intercept, you set x equal to 0. So this gives you 0 minus 4, 0 minus 9, which is 4 over 9. So these are the intercepts. So finding the intercepts, you want to be careful when you're dealing with the fractional format, so don't mess it up. It's very simple. Now, asymptotes. Let me actually clean up my mess. And so you can plot those three pairs, negative 2, 0, 2, 0, 0, 4 over 9. 4 over 9 is like close to 1/2, but it's smaller than 1/2. All right. Asymptotes. Vertical asymptote, the bottom is 0, x equals minus 3, x equals positive 3. So x equals minus 3, x equals positive 3. And then horizontal asymptote, y equals 1. Why is that? Because the degree of the numerator, okay, you can write down the reason. Degree of the numerator is 2. Degree of the denominator is 1. So 1 over 1, that makes it y equals 1. I hope everybody is clear. And whenever you have horizontal asymptote, there is no slant asymptote. So y equals 1, that is the horizontal asymptote. Now remember what we have. We have 1, 2 vertical asymptotes, that we have 1, 2, 3 subintervals. To the left of this point, to the left of x equals minus 3, we pick a point because for the left class, it becomes either this or that. And it's clear that because we don't have an x-intercept here, it's over here. For the beyond this number, the same thing. And again, we don't have another x-intercept. It has to be this one. Do you follow what I'm saying? And this one, do you already have this point? So it has to be like that. So it's very straightforward. There's really not much you have to do. However, if we want to pick extra points, we would pick to the left of negative 3, like negative 4, and to the right positive 4, and evaluate it. So if we put negative 4 or positive 4, by the way, makes no difference. They give us the same answer. A negative 4 quantity squared 16 minus 4 is 12. And negative 4 squared 16 minus 9 is 7. So in both cases, we get 12 over 7. So those are the 2 points, and these are the graphs. So we're done with the graphing. Let's go back to the question, what are we interested in? Greater than or equal to 0? Okay, which portion is above the x-axis? Where is this function greater than or equal to 0? This 3 portions in green. This means from negative infinity to negative 3, union from negative 2 to 2, negative 2 and 2 are included because of the equality, and union 3 to infinity. So x is less than negative 3, or between negative 2 and 2, or larger than 3. In the interval format, negative infinity to negative 3, union negative to 2, and both of them have brackets because those 2 points are excluded and included because we have the equality, union 3 to infinity. Again, this is using the graph. We want to solve this rational inequality. What if one side is not 0? it is extremely important to bring everything to one side. This is the fastest and easiest way. And set one side equal to 0. Whether it's a number or expression makes no difference. Bring everything to the same side. Combine them into one fraction. So that means this is negative 3x minus 6 divided by x plus 2. Please understand, this means this is negative 3 times x plus 2, negative 3x minus 6 over x plus 2. That's the meaning of it. Okay. This is what you get. These two combine. These two combine. And now this is the one we deal with. Never mind the rest. And to do that, you set the top equal to 0, you get x equals 1. You set the bottom equal to 0, you get negative 2. Those are the two values that we have to put on a number line. What makes the top 0? What makes the bottom 0? Okay. So you have a number line from negative to positive infinity, and you put those two numbers, negative 2 and 1, in order from smallest to largest. And now we're going to use TP. Remember, TP short for test point. So we're going to pick negative 3 here. The easiest point is 0 here and 2 here. And by the way, the degree of the numerator is 1. The degree of the denominator is 1. That means the degree is odd. So they alternate. The easiest one would be to plug in 0. If I plug in 0, I get negative 1 over positive 2. I get negative here. And they alternate, positive and positive. See? By the way, at negative 2 is undefined. At 1 is 0. And I showed that in between, when I pick 0, I get negative 1/2. I'm not interested in negative 1/2. I'm interested in the sign of that number. Now, if you have doubts, you can put negative 3. Negative 3 minus 1 is minus 4. Negative 3 plus 2 is negative 1. Negative over negative is positive. But like I said, the reason they alternate, the degree of the numerator is 1 or odd. The degree of the denominator is odd also. So that's the answer. Going back to the question, what do we want? Greater than or equal. So this area and this area, meaning from negative infinity to negative 2. And since this says undefined, negative 2 is not included, use parentheses. And from 1 to infinity, because at 1 becomes 0, that you get bracket. So one more time. From negative infinity to negative 2, parentheses. By the way, negative and positive infinity, always they take parentheses because they are concepts, not numbers. At 1 becomes 0. If it didn't have the equality, it would be the parentheses, but we do, so that's good. Bracket 1 to 1. Comma infinity. It's very straightforward, everybody. Just for the sake of argument, if we had, everybody, instead of this, if we had x minus 1 times x plus 2 greater than or equal to 0, we would use the same thing. And the answer for that would be minus infinity minus 2. Now, because it's greater than, we bracket. Okay, union. Bracket 1 to infinity in case we had this. So I want you to distinguish between this. When the denominator is involved, you have to be careful what to exclude. This one doesn't have any denominators and uses the same number line. Instead of undefined, we would put 0 here. Okay. Let's look at this one. As you know, when you have an index which is odd, or when you don't write the index is odd, so you set this one greater than or equal to 0. If you set the top equal to 0, you get 2. The bottom equal to 0, you get negative 4. You go with the number line and you put negative 4 and positive 2 on that. Okay. We're going to go from negative to positive infinity. At negative 4, the expression is UD, undefined. At 2, the expression is 0. And again, because the degree of the numerator is 1 and the denominator is 1, they alternate. All you have to do, pick a TP. So in between here, we have -5. And the easiest number would be 0 between a negative positive and let's say 3 here. So if you plug in 0, you get -2 over +4. So negative over positive is negative. If this is negative, everybody, if this is negative, then they alternate. But if you have doubts, just plug in. And you see that plug in meaning plug in the -5 with -2 is -7. -5 and 4 is -1. Negative over negative is positive. Going back to the question, we want positive. Therefore, it's this one and this one. From -infinity to -4 union 2 to infinity. Of course, -4 is undefined, is not included. We write it in the following manner. -infinity to -4. Both of them take parentheses. -4 is part of the denominator union. 2 to infinity. 2 takes bracket because 2 belongs to the numerator and we have the equality, makes the expression 0, and that's okay.